So for this, we have a few examples here where we want to convert the following from polar to rectangular, where we have the equation r equals 4, theta equals 3 pi over 4, r equals 10 sine of theta, and r equals -2 secant of theta. And I'll say it looks like we've got a lot that we're going to be doing here. It is a fair amount, but it's important to understand that we have some patterns that are worth seeing at least once each with this. So when we have r equals 4, we should understand that what we're looking at there is the set of points whose radius from the origin is 4. So we should understand that this should be circular, and to get it technically, what we do is we take that r equals 4, we multiply both sides by themselves, that is we square them, we get r squared equals 16, and then you turn r squared into x squared plus y squared, you get x squared plus y squared equals 16, which has the graph like so. Where, again, you should understand that if we have something of that form r equals k, we are getting a circle of radius k, where you make a conversion by squaring both sides. On the other hand, for our second example, that theta equals 3 pi over 4, what we're going to do there is use our relationship in terms of tangent. That is, tangent of theta is equal to 3 pi over 4, or y over x is equal to -1, which says that x is equal to -y, which will have a graph like so. So we should understand that when we just have an equation that gives us a value theta, we're talking about a specific rotation, a set of points that are a specific rotation along, which will be a diagonal line through the origin, where how much that thing spins, the exact arrangement of that rotation, the constant multiple, is going to be determined by what that theta value is. In our third case, we have r equals 10 sine theta, and whenever we have a sine or cosine by itself, we want to multiply in an r, so we can put it in terms of one of those guys. So multiply both sides by r, we get r squared equals 10r sine theta, which we can turn into x squared plus y squared equals 10y. Pull it over and we get x squared plus y squared minus 10y equals 0. And to get this into a nice form, we're going to do something that most people don't like. We're going to complete the square. Where we're going to recognize that to get a perfect square polynomial in there, we have a y square and a minus 2 times 5. So we need to add in a 5 squared, that is 25, to get x squared plus y squared minus 10y plus 25 equals 25, because that allows us to turn this into x squared plus y minus 5 quantity squared equals 25, which comes up like so. So we should understand that when we just have a equation r equals some sine or cosine, what we'll end up with is a circle that has been taken away from the origin, either up or down if we've got sines, or to the left or right if we've got cosines, where the exact radius, the position, all that stuff depends on exactly what terms we have, but the strategy there is to multiply in an r so we can replace it with x's and y's. And then for our fourth and final case, we have r equals -2 secant. It's not so great, but we can remember that secant is 1 over cosine, so we can say that r is instead equal to -2 over cosine. Pull the cosine over, and we have r cosine is equal to -2, or x is equal to -2. So when we have things like cosine and cosecant, which we can see the picture of right here, what we end up getting are vertical and horizontal lines, where we get vertical lines when they're in terms of secants, whose position is determined by the constant multiple, and we get horizontal lines for cosecants, whose positions will be determined by, again, that constant we have tacked on. So here we're getting more of a sense of what these things look like as pictures, what we can get from polar equations in terms of rectangular equations, rectangular to polar, and just a general smattering of the flavor, as it were. I don't expect you to know all of these relationships just from seeing these videos or just from getting a little bit of practice in the homework. It's not the sort of thing that comes immediately because this is kind of odd stuff. It's very different from what you've seen before, probably. But what we'll see next, what we'll see in section 6.4, is how we can develop these relationships a little bit better. That is, we'll see how we can make these pictures a little bit more. We'll look at how we can graph our polar equations. But that's what we'll see next. I'll see you then.